Hello class 8 students, wish you all a very happy new year. Now I hope that you all had a great time during the winter vacation. So let us begin the classes again and welcome back to your physics class. Today we'll start chapter number 7, sound. Now children, you've already done in junior classes. What do you mean by sound? Sound is a form of energy that produces sensation of hearing in your ears. And two very important factors related to sound is that sound is always produced by a vibrating body. That means a vibrating body is the source of sound. Whenever a body vibrates, it produces sound. For example, you take a rubber band and if you stretch it between your mouth and one other end in your hand and you pluck it, then the string begins to vibrate and the sound is heard. So very important thing related to sound is that vibrating body. Another important factor related to sound is that medium. A medium is always required for the propagation of sound. The sound produced by the source, by the body is transmitted through the medium and then it reaches our ears. Sound cannot travel through vacuum. Therefore, the people cannot hear each other on the moon or in the space because there is no atmosphere, no air, no medium. So sound always requires a medium to travel. Now, the speed of sound. Sound can travel through all the media. Sound can travel through solids, sound can travel through liquids, and sound can travel through gases. And the speed of sound in solids is greater than the speed of sound in liquids. And it is greater than the speed of sound in gases. That means that a sound travels fastest in solids and slowest in gases. So when a body vibrates, the particles of the medium also start vibrating. And during vibration, the kinetic energy of the particles changes into potential energy and then again potential energy into kinetic energy. That is why we call sound as a form of energy. Now I will tell you the propagation of sound in air, how the sound travels in air. When the source of sound vibrates, it creates a periodic disturbance in the medium near it. The disturbance then travels in the medium in the form of waves. For example, you take a vertical metal stripe which is fixed at its low end. This is fixed. Now you push the upper end of the metal stripe to one side and then you release it. As it vibrates, vibration means alternately to right and left it moves and it produces sound. Now this first figure shows the mean position, steady position of the metal stripe and the normal condition of the air layers near the stripe. Now as the stripe moves to the right, it pushes the particles of air layer in front of it. So the particles of air in this layer come closer to each other. That is, the air in that layer gets compressed and this is called compression. And we denote compression by C. When the particles are close together, that is called compression. The particles of this layer while moving towards right pushes and compresses the layer next to it, which then compresses the next layer and so on, and thus the disturbance moves forward in the form of compression. Now as the metal stripe returning back to its original position, the compression C moves forward and the particles of air near the stripe return back to the normal position due to the elasticity of the medium. Only compression is moving. They again come back to the original position. Now when the stripe moves to the left, it pulls the layer of air near it towards the left and thus produces a space of very low pressure on its right side. the air layers on the right side of the stripe expand in this region, thus forming rarefaction. That means region of low pressure when the air layers are far apart. That is called rarefaction. By the time the stripe returns back from this position again to its mean position, the refraction R moves forward and the air layers near the stripe again return back to the normal position to the elasticity of the medium. In this manner, as the stripe moves to the right and left repeatedly, the compression and rarefaction regions are produced one after the other, which carry the disturbance along it with a definite speed depending on the nature of the medium. And one complete to and fro of the stripe forms one compression and one rarefaction, which together constitute one wave. So one wave is composed of one compression and one rarefaction. The sound travels in air in the form of longitudinal waves. This type of wave, which travels in the form of compression and rarefaction, is known as longitudinal wave. Now I will tell you the representation of a wave. This is the displacement time graph. Displacement in meters and time in seconds. This is how you represent the wave. Now some very important terms related to the wave. Amplitude. The maximum displacement of the particle of the medium on either side of the mean position is called the amplitude. This distance. This is the maximum displacement from mean position. So this vertical displacement, vertical distance is called the amplitude on both the sides. On positive axis also, on negative axis also. It is denoted by the letter A and its SI unit is meter. Now the time period. The time taken by the particle of the medium to complete its one vibration is called one time period. See this, one vibration, or this is also taken as one vibration for the top point or bottommost point. So the time period is represented by the letter T and its SI unit is second. Frequency. The number of vibrations produced by the particle of the medium in 1 second is called the frequency. It is also defined as the number of waves passing through a point in 1 second, and it is denoted by the letter F and its SI unit is Hertz. SI unit of frequency is Hertz. Now the frequency is the characteristic of the source which produces the sound. It does not depend on the amplitude of vibration or on the nature of the medium through which the wave propagates. Now, very important relation between time period and frequency. Children, you have understood the time period. The time taken for one vibration is called time period, and the number of vibrations made in 1 second is called the frequency. So, in time t, the number of waves is 1. One wave is taking time t. So in 1 second, number of waves means frequency F will be 1 upon t. So this is the relation between frequency and time period. Frequency equals to 1 upon time period, or time period equals to 1 upon frequency. Now children, this was the displacement time graph. If you replace this time by distance, so it becomes the distance time graph, and then this distance travelled by the wave in one time period of vibration is called its wavelength. Okay children, the distance travelled, earlier it was the time, the distance travelled by the wave in time, one time period is called its wavelength, and it is denoted by the letter lambda, and the SI unit of wavelength is meter, and it always depends on the nature of the medium through which the wave travels. In longitudinal wave, the distance between two consecutive compressions or two consecutive rarefactions, consecutive means one after the other, that is called wavelength.